Okay, angles. So let's start with some basic terminology. So an angle is defined as the union of two rays. One is called the initial side, and the other is called the terminal side. And the point where they intersect is called the vertex of the angle. Okay, now we're going to measure angles two different ways in this course using degrees and radians, but radians won't come until chapter 3. So this particular angle would read from the initial side to the terminal side, and this one might measure, say, 30 degrees. All right, and let's define what a degree is. 1 degree is 1/360th of a full rotation. Okay, so this tells us that there are 360 degrees in a full rotation. Also, we use Greek letters frequently to denote angles. So most commonly is theta. But also alpha, beta, and gamma are fairly common. There are also occasions, typically when we're working with triangles, where we will use capital letters for angles. Okay, let's look at some angle classifications. So an angle between 0 degrees and 90 degrees is called an acute angle. An angle measuring exactly 90 degrees is called a right angle. An angle measuring between 90 degrees and 180 degrees is called an obtuse angle.
What did you call me?
And finally, an angle measuring exactly 180 degrees is called a straight angle. All right, and we often denote right angles visually in a diagram using a little box corner like this. All right, let's talk about two important angle relationships. We would say that alpha and beta are complementary angles if alpha plus beta add up to 90 degrees. And we would say that alpha and beta are supplementary angles if their measures add up to 180 degrees. All right, so here are a few illustrations of situations where you might have complementary angles. So if you have a right angle and you just split it into two smaller angles, here we can say alpha and beta are complementary, because you can see just from the diagram that together they make up 90 degrees. All right, and supplementary shows up this way, because together they complete 180 degrees. Okay, but complementary and supplementary don't always show up in this perfectly obvious situation. The three angle measures in a triangle always add to 180 degrees. What this does tell us is that if you have a right triangle, and we will work with right triangles quite a bit in this course, okay, then your right triangle will have two acute angles. Let's call them alpha and beta. And those angles are complementary. Okay, because you have 180 degrees to distribute among the three angles, 90 degrees of which are occupied by the right angle, which means the remaining 90 are split between the alpha and the beta there, making those angles complementary. Okay, so here we just have to find the measure of the two angles in the problem, this one and this one. And we can see right away that they're complementary because they appear to add up to 90 degrees. So, therefore, and incidentally, these three dots in math mean therefore. So because the two angles are complementary, therefore 2x, the smaller angle, plus 3x, the larger angle, equal 90 degrees. All right, so we'll just solve this equation for x. So 2x plus 3x is 5x. 5x is 90 degrees. And dividing both sides by 5, we get that x is equal to 18 degrees. So now that we know the value of x, we can plug x into each of those two individual angles and actually learn what their measures are. So the 2x angle is 2 times 18 degrees, which is 36 degrees. And the 3x angle is 3 times 18 degrees, which is 54 degrees. So our conclusion is that the two angles measure 36 degrees and 54 degrees. And there we are. Okay, it's common for degree measure to be further divided into minutes and even minutes to be further divided into seconds. Now, this has nothing to do with time, like minutes and seconds in time. These are just terms that we use to get even more precise measurements of angles. This system is commonly just abbreviated DMS, degrees, minutes, seconds. So 1 minute is denoted one with like an apostrophe there, and that is 1/60th of a degree. In other words, there are 60 minutes in 1 degree. Okay? And 1 second is one with 2 apostrophes. That is 1/60th of a minute, or 1/3600th of a degree. Okay, in other words, 60 seconds is 1 minute, or 3,600 seconds is 1 degree. So a second is very, very, very precise for an angle. Okay, now just the naming actually helps us remember this system in a sense, if you know how time works, of course, because just think of a degree like an hour, and an hour has 60 minutes and a minute has 60 seconds. And if you just understand that breakdown, then it's exactly the same right here, except instead of the word hour, we're using degrees, and everything's measuring angles. All right, this is how an angle is typically presented when given in degrees, minutes, and seconds. So what we want to do is convert this to decimal degrees. So our answer will be 105 point something degrees. So 105 degrees, 20 minutes, 32 seconds. That can be regarded as 105 degrees plus 20 minutes plus 32 seconds. Okay, now just convert each one to degrees. So this would be like 105 degrees plus 20 divided by 60 degrees plus 32 divided by 3600 degrees, because 1 second is 1/3600th of a degree. Okay, using a calculator, comes up with this number, with the 2's repeating. This question said round to the nearest thousandth. That would be 3 places after the decimal. So we're going to say that's 105.342 degrees. Final answer. All right, so here we're going to convert the other way. We have an angle given in decimal degrees, and we seek its form in DMS. Now, let me give a little context for all this converting that we're doing. Oftentimes, you'll be working out a problem and the measurements will be given in DMS, but you need to do calculations, and it's a lot easier to do calculations mathematically when an angle is given in decimal degrees. But once you're finished all the calculations and you want to present your final answer, it should be formatted in the same way that the original problem was posed. So if a problem was given in DMS, we need to take whatever our angle is, let's say we got 85.263, and convert it to DMS. So how would we do that? Well, we know the degrees is going to be 85, right? So the 85 degrees is given. So it's the 0.263 that we need to deal with. Okay, so what we're going to do, we're going to take the 0.263 and we're going to figure out how many minutes that is by multiplying by 60. So on my calculator, I multiplied 0.263 by 60 and got 15.78 minutes. Okay, so we know that this is going to be 85 degrees, 15 minutes, and then the 0.78, now that's leftover stuff, and we need to convert that into seconds. And we go from minutes to seconds, again by multiplying by 60. Okay, so multiplying 0.78 by 60 gives 46.8. So now writing this in DMS format would be 85 degrees, 15 minutes, and let's round to the nearest second, so 47 seconds. Okay, we round to the nearest second because we just didn't have enough precision in the original problem. 1/1000th of a degree has the same approximate precision as a whole second, not as a tenth of a second. Okay, adding degree measures in DMS is fairly straightforward. One way you could always do this is, of course, converting both of them to decimal degrees, then doing the addition the classic way, and with your decimal answer, converting it back to DMS. But it's pretty straightforward to just do this directly in DMS. So we're just going to line these up, 28 degrees, 35 minutes, and 63 degrees, 52 minutes. And we're going to add the degrees and we're going to add the minutes. So for instance, if we added the degrees together, we would get 91 degrees. And if we added the minutes together, we would get 87 minutes. Okay, so our answer preliminarily would be 91 degrees, 87 minutes. However, the minutes cannot exceed 59. And if there were seconds, the same theory would apply. So to rectify this, we will subtract 60 minutes. And simultaneously, we're going to add 1 degree. So this will have no effect on the actual value of the number, except adding 1 degree, we go from 91 to 92 degrees, and subtracting 60 minutes will put us down to 27 minutes from 87. And that's formatted correctly. So we're done. All right, so the supplement, if you recall, means we're after 180 degrees minus 117 degrees 29 minutes. So if we were to proceed in the manner that we did before, we would write 180 degrees And then underneath, 117 degrees, 29 minutes. Okay, but there's nothing to subtract the 29 degrees from, right? And even if there were something there, there's still an issue that you might run into. What if we were told to find 180 degrees and 25 minutes minus 117.29, right? You wouldn't want to put like -4 minutes here, okay? That's problematic. So in that type of situation, what we're going to do is we're going to rewrite the 180 to 179 degrees, 60 minutes. Now we can do the subtraction. 60 minutes minus 29 minutes, that's 31 minutes. And 179 degrees minus 117 degrees is 62 degrees. So there's our final answer. 62 degrees, 31 minutes. So we can conclude that the supplement of 117 degrees, 29 minutes is 62 degrees, 31 minutes. Okay, for much of the content in this course, we will be referring to angles in what's called standard position. So that means angles whose vertex is at the origin of the xy coordinate plane and whose initial side coincides with the positive direction of the x-axis. Okay, so the positive x-axis corresponds to the initial side of all angles in standard position. The vertex is at the origin, and the terminal side is just, well, anywhere else pointing in any direction here. Okay, so we would read the angle theta in here, perhaps, from the initial side to the terminal side. So based on where a terminal side is located, we can talk about the quadrant of an angle. And this particular angle that we've drawn is in quadrant 1. The quadrants read 1 through 4 counterclockwise. They're often represented with Roman numerals, but that's not a law. Okay, and the quadrants for angles between 0 and 360 degrees are so defined. Okay, now angles that are exactly equal to 90 degrees, 180 degrees, 270, 360, etc., those are called quadrantal angles. All right. So let's take a quick look at an angle in standard position. So in standard position, that means the initial side of the 30 degrees coincides with the positive x-axis, and the terminal side will be 30 degrees away. Now, it's important to stress that we can have negative angles. So positive 30 means we are reading counterclockwise from the initial side. So that would swing us up this way. And there's our 30 degrees, which is read counterclockwise from the initial side to the terminal side. Positive angles are read counterclockwise. And in contrast, negative angles are read clockwise. So an angle of 30 degrees is unambiguously in the first quadrant as we've drawn it. But if we were asked to draw an angle of negative 30 degrees in standard position, well, that would swing downward from the initial side, and that would be in the fourth quadrant. Well, now what would an angle of 390 degrees look like? What if we took this 30-degree angle and we added 360 degrees to that? Okay, so that would actually be, there's an angle of 360 and then plus 30 more. So now we have 360 degrees plus 30 degrees, which would be a 390-degree angle. And that angle has the same initial side, of course, they all do, of the positive x-axis, but it also has the same terminal side as the 30-degree angle does. Okay, in that situation, we would say that 30 degrees and 390 degrees are coterminal. So for example, 30 degrees and 390 degrees are coterminal. Okay, coterminal angles always differ by a multiple of 360 degrees. Now, we could have added another 360 degrees to this. In fact, we could have gone around, 50 times and then stopping again at that same terminal side. And what the measure of that angle would be 50 times 360 plus 30, right? Okay, and for that matter, we could have this negative angle right here. So this is negative because it's reading clockwise from the initial side. And that particular angle would be like 30 degrees minus 360. So that would be negative 330 degrees. And negative 330 degrees is also coterminal. It's part of this family. Okay. There are an infinite number of coterminal angles to any given angle. So every angle, in fact, is coterminal to some angle in the interval 0 degrees to 360 degrees. And we use a bracket for 0 because we're including the 0, but a parenthesis for 360 because we're not including that since the angle 360 itself is coterminal to 0. All right, well, since every angle is coterminal to something from 0 to 360, that means we ought to be able to take an angle like 1,106 degrees and figure out what it's coterminal to between 0 and 360. So let's look at that guy. The way we do that is just by successively subtracting 360 degrees until we're in the target interval. So subtracting 360 degrees one time will give us 746 degrees. That's too big, so we'll do it again. And now we get 386 degrees as a result. Still too big, so do it again. And we get 26 degrees. And 26 degrees is between 0 and 360, so we're good. All right, now obviously you could save some time if you learn that you can subtract bigger chunks, like 2 times 360 is 720, 3 times 360 is 1080. So knowing that a 1106 is larger than 1080, we could have just subtracted 1080 right away and gotten 26. All right. So the value here is that if out of the blue you were working with the angle 1106 degrees, but you needed to know what quadrant it's in, well, it's not obvious, right? But if we know that 1106 is coterminal to 26 degrees, then we're able to draw it in standard position. Since we know 26 degrees is in the first quadrant, it's about like so. And 1106 is going to land there as well. It's just going to go around 3 times first for absolutely no reason. So we'll go around once, twice, third time. So there's 1106 degrees. So we can say 26 degrees and 1106 degrees are coterminal, and they're in quadrant 1. Okay, for part B, we were given negative 150 degrees. Okay, so just a negative angle, so we'll just continue to add 360. All right, I have a good feeling that we'll only need to do this one time. So this comes out to 210 degrees. All right, and the sketch, which can just fit in here. Well, we know 210 degrees is greater than 180. So 210 degrees is about here in standard position. And the negative 150 is just read as a negative angle, so clockwise. And you can see that, of course, they are coterminal and they're in quadrant 3. All right, so here we just are asked to list all of the angles that are coterminal to 12 degrees. So we could start with 12 degrees, and if we add 360 to that, we'll get something coterminal to it. So 360 plus 12 is 372. And we could add 360 to that, which would give us 732. And we could actually keep going. That process goes on forever. So it's not really possible to list them all. But just to make problems even worse, we actually can subtract 360 and go in the other direction. So if we were to subtract 360 degrees from 12, we would get negative 348 degrees. And we could subtract 360 from that. We could do this all day, right? We get negative 708. And so the list is infinite on both ends. So, okay, what do we do? So instead, what we say is we're talking about the set of numbers satisfying this condition. 12 degrees plus a multiple of 360 degrees. Okay, and we stipulate that n is an integer. So now, when n is equal to 0, that's like 12 plus 0 times 360, well, that's the 12. When n is equal to 1, that's 12 plus 360 times 1, that's the 372. Okay, when n is equal to, say, negative 5, that'll be 12 times 360 times negative 5, and whatever that is, it'll be somewhere on the left in our list. Okay, so that's how we present an answer like that. Now, one more thing. This sentence, n is an integer, is so common in math that we have a notation for it that I'm going to use fairly frequently, which is that. And the parts read as, of course, this is just n, but this little guy, sort of a C that's trying to be an E, means is an element of, and this double stroke capital Z is the set of integers. So this reads as n is an element of the set of integers. Okay. All right, so that's section 1.1.